Hello learners, welcome. So today we are trying to solve a problem on projection of lines. The problem which we are trying to solve is that a line AB 70 mm long is inclined at 30 degree to HP and 45 degrees to VP. Point A is 10 mm above HP and 20 mm in front of VP. So we are supposed to draw the projections of line AB and while considering that point B is in first quadrant. So in order to start with this problem, initially, I will take the line thickness as 0.09 mm. Then I will start with drawing the XY line, which will be my reference line. On this reference line, I will select the point location where point A will be lying. So let's say this is the point. So from here, I will draw the vertical line to show the point A 10 mm above HP, and same way I will draw its top view, which is 20 mm in front of VP. I will just name these lines, name these points. So this point is A dash, the front view of point A, and the second point here is point A, which is the top view of point A. Just adjusting them near the point itself so that it will be easier to understand. Now once we are done with that, we can move ahead. Now as we know that line AB is 70 mm long, so from point A dash I can draw the true length of 70 mm, and this true length is supposed to be inclined at 30 degrees to HP. So I will mark it at 30 degrees to HP. So this will be my true length, and the point will be point B1 dash, which is a partial front view of the point B. Same way I can I can complete this partial front view. So from this front view of point B, partial front view of point B, that is B1 dash, I will draw a projector, and on the projector I will draw locus from point A where the two intersect. I can name it as point B1, which is the top view or partial top view of the point B. Just a bit. Now once I am done with this, I will move to second condition where the inclination of the line given with the VP. So I will start the line from point A. Again, I will be drawing its true length, that is 70 mm, and this time the length will be inclined at 45 degrees to XY line. Since the inclination is in the below XY, so I will make it as minus 45 degrees. Take it as again minus 45 degrees. So now the inclination is correct and length is also correct, 70 mm. So I will mark it. Once I am done with this, the point here which I got will be point B2. That means the again it's a apparent position of the top view of point B. As per the earlier process, again I can draw a projector from point B2 and draw a locus from point A dash, and where both will intersect, that will be my point B2 dash. So this covers the given part of the problem. Let me adjust point B2 a bit so that it will be easier to understand. Yeah. So with this, we have done the initial part of the problem. Now we know that point B dash should lie on the locus of point B1. The actual point B dash should lie on the locus of point B1 dash, and the distance from A dash should be equivalent to B2 dash. So to achieve that, I can I can take a start center type. I can take a center type arc. So I will start over here, mark A dash as the center, and then I can draw the arc so that it will intersect the locus here. Now where it intersects, this will be my point B2, sorry, B dash, because it solves all the requirements of B1 dash as well as B2 dash. Now same way I can draw locus of point B from point B2. Again on this locus I had to make sure that the actual length of A to B is equal to length of A to B1. Again I will take the arc. So I'm taking the start center end type arc. So I'm starting with point B1, marking A as the center, and then I'm trying to find out the point where it intersects with the locus. Now you can see the arc is getting on the other side than what is required. So in such cases I can just press Control on keyboard, and then I can change the direction in which the arc will be drawn. So this is how I can draw the arc. So I got the look at the position where point B1 after rotation intersects the locus drawn from B2. So this point will be my actual point B. So once I'm done with this, I will have to just make ensure whether points B and B dash are along one single straight line, because as the theory of projection both the points must be along one same line, which they are. So that means the solution which is drawn for the problem is correct. I will draw point A dash, so draw the lines A dash and B dash, so that those will be the final positions of the actual point or actual line. These are the projections which you are supposed to draw. And since this is the actual view of the line, I will dark it. I'll make it dark by selecting a darker thickness for those lines, just to ensure that all the given data is properly added in the figure. I will do some checking. That means I will just make sure that the true length is 70 mm in both front view and top view. The inclinations which are marked at 30° to HP and at 45 degrees to BP, and height at which point A and A dash are, and the height at which point A and A dash are also correct. That also I will have to ensure. So this is 10 point A was 10 mm above HP and 20 in front of BP. So with this much we have completed the problem correctly, and this is the solution which can be drawn for the given problem. Thank you.